Namaste and welcome to CADEC learning series. In this video, we'll use a simple product class to understand how to make a simple configurator. The product class that we'll be choosing this time is a sheet metal enclosure. It has a body, top and bottom cover, door, mounting plate, cable plate, hinges, locks, etc. So first, we'll create a uh, blank assembly and create a product class for this configurator. So I'll create an assembly. Let's save this. This is the CADEC toolbar in SolidWorks Command Manager. So I'll just click on any of these functionalities. Let's say crawl, and it says, do you want to create a configuration database for the assembly? I'll click yes. Okay. So now a configuration database for this particular product class is created. So this is Enclosure CDC is the configuration database, and Enclosure SLDSM is our assembly. Okay. So we'll first start with defining the variations in this enclosure. So we'll define the shape variables. This enclosure has a single door, so we'll have a variation whether the hinges are on left or right side. So I'll type the variable name as door hinge, and the options for this the user can choose either on left side or on right side. The next variation is whether a bottom cable plate is required or not. So yes, no. Then inside on the back, the whether a mounting plate is required or not. Uh, the enclosure will have a door and the door can be locked. So uh, we will have a variable what is the lock make. I mean, who is the manufacturer whose locks will be used in the for the door. So we'll have a variable lock make, and we'll say manufacturer A or manufacturer B. Then we'll allow the user to define whether what is the material of the body uh, and door and the mounting plate. So we'll have a variable body material. The options are either stainless steel or mild steel. Then door material, again stainless steel or mild steel, and other plates material. So these are the mounting plate, mounting bracket, cable plate, etc. So here we'll have, let's say, stainless steel, mild steel. Let's say we have option of GI also. So we have created some variations which we call as shape variations, because this requires suppressing, unsuppressing some features or parts in CADEC. So let's see what user interface CADEC has generated for this shape variation. So I'll choose an enclosure, and it shows that door hinge, left, right, cable plate, yes, no, required, mounting plate, block plate, etc. So next is we'll create some size variations also. Since this enclosure will have some length, width, height, and based on that, various of the inside components can be uh, dimensioned. So we'll create some size variables also. So I'll start creating some variables. Let's say enclosure height, width, depth, then body thickness, door thickness, then mounting plate thickness, cable plate thickness. Then we'll have some formula for the mounting plate height, and let's say the formula is mounting plate height is equal to enclosure height minus 60 mm, and mounting plate width, let's say the formula is mounting plate width is equal to enclosure width minus 60 mm. And then we'll have cable plate width and cable plate depth. Since cable plate is on the bottom and it will have width and a depth, and we'll have the formula for that also. So cable plate width is equal to enclosure width minus 70 mm, and cable plate depth equal to enclosure depth minus 70 mm. We'll also create some more variables for uh, deciding how many locks will be required for the door. The number of locks depends on the height of the door. So let's say every 300 mm we want a lock. So we'll have a simple formula of how the number of locks increases as the height of the door increases. So we'll have a variable called uh, lock number and lock pitch. So for lock number, we'll have a formula if enclosure height is less than 301, then we'll have one lock or two locks. So, but if the enclosure height increases beyond 600, we'll have three locks. So we'll just copy and paste this again here and in here. So if enclosure height is less than 301, then it will be 1. Else, if enclosure height is less than 601, it will be 2. Else, if enclosure height is less than 801, it will be 3 or 4. Let's add this. Now we'll have a formula for lock pitch. So lock pitch will be uh, the distance between first and last uh, lock divided by number of locks minus 1, because the number of pitches will be locks minus 1. So and the standard distance below the first lock and above the last lock is 50 mm. So I'll give the formula of lock pitch is equal to enclosure height minus 100 divided by lock number minus 1. Again, I'll give a bracket for this lock number minus 1 also. Okay, so I'll save this. So let's see whether and how our calculations are being calculated. So I'll just choose something here. We have not made any model, so there is no model modification going to happen. I'm just checking the calculation. So let's say the enclosure height is 1500 mm, enclosure width is 600 mm, enclosure depth is 500 mm, body thickness is 2, door thickness is 2, mounting plate thickness is 1.5, cable plate thickness is 1.5. Okay, I will give some layout ID. So this is test ENCL01. I'm creating a output, but output will have no geometry. The output is created in CADEC outputs test ENCL01 folder. Uh, let's calculate. So the mounting plate height and width is 60 mm less than the enclosure height and width. Cable plate height and width and depth will be 70 mm less than the enclosure width and depth. Now the lock number it has found is 4, and lock pitch it has calculated 466.66. So this covers our first uh, video on enclosure uh, design calculations or enclosure formulator. Thank you.